Hello, welcome to PTC Aviation Academy. I'm Captain Lakshmi Mohan, and today we are going to talk about a topic called as stability and controllability. So why stability and controllability? Because stability and controllability in an aircraft is supposed to be in balance with each other. That is, if stability is more, what happens, it will be very difficult for the pilot to control the control column and hence for the aircraft. And if the controllability is too much compared to stability, what happens is tiny movements in your control column will have drastic changes in the aircraft. So this leads to uncontrollability eventually in an aircraft. So the aircraft, either way, if stability is more or controllability is more, it will be very difficult for the pilot to control the aircraft. So this is the reason why we need to understand what is stability, what is controllability, and how to balance them both. So let's get started. So first of all, in order to understand stability and controllability, let's talk about the components of the aircraft. Now, aircraft is a machine, right? So any machine, to be called it a specific thing, like for example, you have a fan. Okay, in order to call something a fan, you need to have, it needs to have a blade, it needs to have motors, etc., etc. Similarly, aircraft is also a machine. Now, in order to call that particular machine aircraft, it needs to have a certain components. So these are some of the components. So first of all, you need a space to get your all the weight of the aircraft, that is to put your passengers on, to put your baggage, mail, cargo, to put all the aircraft equipments, the aircraft computers, housing for the cockpit. All that is kept in the fuselage of the aircraft. Okay, and then you have the wings of the aircraft, which is the next thing, basically used to create lift in the aircraft. Okay, so wings are for lift, then we have engines for the thrust, then we have your landing gears for takeoff and landing, and then you have some secondary flight controls which we'll study later, and then lastly you have something called as empennage. Now empennage is, why I kept it in the last, is to give it, like, explain it a little bit in detail. Now in empennage, or the back part of the aircraft, if you see, there are two prominent surfaces, that is your called as something that sticks out on top, that is called as your vertical stabilizer, and something that comes out like a miniature version of a wing. This is called as your horizontal stabilizer. Attached to this vertical stabilizer and horizontal stabilizer are two movable parts. So attached to the vertical stabilizer you have the rudder, and attached to the horizontal stabilizer you have elevators. So this is basically how the empennage is structured, and in coming parts of the video we will talk more about all these structures. Okay, so understood the components of the aircraft, right? Now moving on to the axis of the aircraft. Now axis of the aircraft, if you see in this video, the axis of the aircraft, you have three axes. That is the longitudinal axis, which extends from the nose of the aircraft to the tail of the aircraft. Then we have the lateral axis, which ends from the which starts from one wingtip to the other wingtip, and the third is your vertical axis, which goes from the upper to lower surface of the aircraft. So these are the three axes of your aircraft. Now these three axes of the aircraft, all three of it intersects at a point called the center of gravity. In a previous video I gave you, I also spoke about center of gravity in a previous video, and I said it was an imaginary point where all the weight of the aircraft is concentrated. The same center of gravity is where all the three axes of rotation of the aircraft also intersects in on the center of gravity. And why this happens is because center of gravity, or this imaginary point, is where the entire aircraft is at balance. It is the balancing point of any object, for that matter, not just aircraft. Any object is this center of gravity of that object. Okay, so now let's talk about stability. Stability is in the ability of any object to come back to its original position. Now stability is divided into two types, static and dynamic. So static stability is when you have the object's initial reaction to come back to original position is called static stability, and dynamic stability is basically the reaction of the object once it's moved from its original position over a period of time, whether it's coming back to its original position or moving away, is called as your dynamic stability. Now statics, let's talk a little bit more about static stability. Static stability, if you look at it, you will see in this diagram that the first object that you see over here, now if this object is kept in a plane beneath it which is curved upwards, right? So this particular object, if it is moved to this position, what's going to happen is that if that force is removed, whatever is moving it to this new position, if that force is removed, this object's natural tendency is to come back to its original position. This ability is called as positive static stability or stability. Okay, now coming on to this particular diagram, you will see that here you have the object, and if you apply force and move it to the new direction, now the plane beneath that is a flat surface. So if you move it towards the new position, what happens is that it will stay in this new position, it's not going to come back. This sort of stability is called as neutral static stability or neutral stability. Now when the plane beneath the object is curved downwards, what happens is that if a force is applied to the object and the object moves in this direction, that is, it's moving further away, once the force is removed also it is moving further away from its original position, this object is displaying a negative static stability. So these are the three different types of stability, especially static stability. A negative static stability is also, by the way, called as instability. Okay, so these are the three different types of static stability. Similarly, even in dynamic stability, if you see this particular diagram, you will see that in dynamic stability, you will see that it has got a positive static stability and dynamic, that is positive static stability is that is the object is coming back to its original position, but over a period of time, and the oscillation at which it is moving through is reducing, the amplitude of the oscillation is reducing. This is called as positive dynamic stability. Okay, next we have neutral dynamic stability, where the amplitude is not changing at all, the amplitude is neither increasing nor decreasing, so it's oscillating about a given point. This is called as neutral dynamic stability. And negative dynamic stability is over a period of time its movement or oscillations gets worse. This is called as negative dynamic stability. So understood what is stability, what is static stability and dynamic stability, and what is the different types, that is stability, neutral stability and instability of each static as well as dynamic. Now in the aircraft, in order to give stability to the aircraft, there are two stabilizers which I spoke to you about in the components of the aircraft, that is your horizontal stabilizer and vertical stabilizer. So these two equipments or these two components of the aircraft is what, so the vertical stabilizer basically gives the aircraft stability in this movement, that is your yawing movement. Now this yawing movement happens about the axis, that is your vertical axis, this is your yawing movement. Okay, and the horizontal stabilizer gives you stability over pitching movement. Okay, this pitching movement is happening around the lateral axis, it's a movement of the longitudinal axis, but it is about the lateral axis. Okay, so this is your pitching movement. And another movement that the aircraft has is rolling movement, which happens along the longitudinal, which happens along the lateral axis, but its center, the axis of rotation is your longitudinal axis. These are the three movements of the aircraft. So your elevator gives stability to pitching movement, your your horizontal stabilizer gives stability over your pitching movement, and your vertical stabilizer gives stability over your yawing movement. Okay, so these are the stabilizers that is there in the aircraft. Now moving on to what is controllability. Controllability in an aircraft is basically the controls of the aircraft. Controlling the aircraft is done by control surfaces. There are three types of control surface. You have ailerons, you have rudder and elevator. So I've already spoken to you about rudder and elevator. Now aileron is there, rudder is there on the vertical stabilizer, elevator is there on the horizontal stabilizer, and now ailerons are there on the wings of the aircraft. Okay, so if you see this picture, you will see that the ailerons are the ones which is present in the wings of the aircraft. Okay, and rudder and elevator is in this like I said before, vertical and horizontal stabilizer. Now let's talk about, before we get into the control surface, let's get some terminologies right. So first of all, we have camber line. So in the previous video, I've talked about certain terminology like relative wind, angle of attack, chord line. So similarly, today we are going to talk about a new terminology which is called as camber line. Now, camber line is a line joining the leading and trailing edge of an aerofoil, which is also equidistant from both the upper and lower surface of the aerofoil. Okay, so along with this camber line, you also need to know the terminology of what is chord line, what is angle of attack, what is relative wind. And now when it comes to angle of attack, another thing that I need to mention here is, as the angle of attack increases, the pressure differential and the lift force in an aircraft also increases until a point called as critical angle of attack. Until it reaches critical angle of attack, the lift force continues to increase. Okay, and at this, after this critical angle of attack, something called as stall happens, which will be covered in another video. So as of now, what you need to know is that, and as the angle of attack increases, your lift force also increases. Okay, now coming on to the different types of camber that is there. First of all, you have in this first picture, if you see, you have the zero camber or the symmetrical aerofoil. In a symmetrical aerofoil, what happens is your chord line and your camber line, both of them are at the same place. That means the aerofoil either way, that is, it is equidistant from the top to the center and from the bottom to the center, it is equidistant. So this type of camber is called as symmetrical, or this type of aerofoil is called as a symmetrical aerofoil. Next, coming on to the second diagram here, you will see that the camber line is above the chord line. So when the camber line is above the chord line, this particular type of aerofoil is called as a positively cambered aerofoil. And the last one, if you see this here, if you see, the chord line is above the camber line. So here you have a negatively shaped or negatively cambered aerofoil. So these three different aerofoil is given to the three different types of control surfaces that we have. Like the rudder uses an zero camber or symmetrical aerofoil. So that if there is no pressure on a neutral place, if there is no movement, if the rudder does not move and if it is in its neutral position, the forces that is created either side of the vertical stabilizer is same. So the rudder will not, or the vertical stabilizer will not move if the rudder is in the neutral position. Now when it comes to your positively cambered aerofoil, your ailerons and your wings both are positively cambered aerofoils. Then we have the negatively cambered aerofoil, which is basically the horizontal stabilizer, and I will tell you why it is negatively cambered. Okay, so these are your different types of camber and the different types of control surfaces when it comes to your how the camber of each control surface is. Okay, now let's talk about your ailerons, which is controlling the rolling motion of this aircraft. Okay, so in this diagram, if you see, in the wings you have two different ailerons, right? So one aileron will go down and one aileron will go up. Generally when the control surface is there, let's say you're making a turn to the right side. When you're making a turn to the right side, what happens is that the left aileron will come down and the right aileron will go up. So when the left aileron comes down, see, this is the left aileron. Okay, with this left aileron, see, the camber of the entire thing increases. Camber increases, more camber, so you will get a greater angle of attack. When you get a greater angle of attack, what happens is that you get greater lift. So the left side, if you're turning to the right, the left side wing will receive more lift, the right side wing will receive less lift, making the aircraft move towards the right side or roll, not move, roll towards the right side. And if you see, this one is the right side wing, which is got, so now the aileron has moved upwards, and which means less angle, and when there is lesser angle, the lift created is less compared to this. And now what happens is that when the aircraft is straight and level, it has equal, both the wings are producing equal lift. But when you're turning to one side, this is what happens to the ailerons, and when this was what happens to the ailerons, the aircraft starts to roll towards the right, and the vice versa happens towards the left side. That is, your right aileron will move down and the left aileron will move upwards. Okay, so this is how the aircraft rolls. Okay, now when the aircraft rolls, there is another thing that needs to be considered, called as adverse aileron yaw. Now, adverse yaw or adverse aileron yaw, in my previous video you have understood that along with lift, there's a byproduct of lift called as induced drag. Okay, so when an aircraft is turning to the right, like I said in the previous example, when the aircraft is turning to the right side, left side wing is creating more lift compared to the right side wing. So when left side wing is creating more lift, it is also creating more induced drag. Now this induced drag, so the aircraft wants to move to the right side, but the induced drag will pull the aircraft or yaw the aircraft to the left side, which does not give us the right turning performance of the aircraft. You can counteract this by different methods, with freeze type ailerons, with differential ailerons, or you can simply correct it using your rudder. So freeze type ailerons and differential ailerons both will increase the parasite drag of the aircraft to counteract the induced drag, and then that is what is going to balance out the drag, giving a coordinated turn. This is in some aircraft, but in some smaller aircraft you can use the rudder to counteract for the adverse aileron yaw. Okay, so next, moving on to your elevator. Now elevator, let me explain this to you. Elevator is basically controlling the pitching movement of the aircraft. Okay, now let me tell you this. If you see the center of gravity and center of lift, center of gravity, like I said, is an imaginary point where all the weight is concentrated, and center of lift, or correction, center of pressure, CP, is an imaginary point where all the lift of the aircraft is considered to be concentrated. Now most of the aircraft are manufactured in such a way that the center of gravity is ahead of the center of lift. Now if you look at the diagram, you will see at the center of gravity you have 2000 pounds of aircraft weight. Okay, 2000 pounds acting downwards. Okay, so the aircraft is generally nose heavy, so it will always have a nose down tendency. Now at center of pressure, okay, center of pressure or CP, you will have 2200 pounds of total lift. Why 2000? See, I've told you this, that weight is equal to lift when it comes to 4 forces of flight. So if you see, the weight is only 2000. Why is the lift 2200? That's basically because your horizontal stabilizer, so if the aircraft cannot fly like this, right? So there needs to be some force that keeps the aircraft steady like this. So that force comes from your horizontal stabilizer, which is creating a downward tail down force. It is creating that particular force just similar to how a positively cambered wing creates lift. But lift is in the upward direction. This tail down force or downward force is basically in the downward direction. Just to keep, so this is your center of gravity, keep making the nose heavy. Now this downward force will compensate for that. Now that, let's say it's 200 pounds. Now the total lift is your weight plus your download force in order to keep the aircraft in balance. Okay, so that is what how your elevator controls the pitch. Now same goes with the elevator and the horizontal stabilizer. So if the horizontal if the elevator goes down, the horizontal stabilizer will move up. When the horizontal stabilizer along with the entire empennage moves up, what happens? The nose is going down. Okay, so this is how it works. That is, whichever aerofoil the control surface is attached to, the movement of, if the movement of the control surface is in one direction, the movement of where the control surface attached to will go in the opposite direction. So if you have the elevator going down, the entire empennage and horizontal stabilizer will go up and the nose of the aircraft will go down. Similarly, if the elevator goes up, the entire empennage and the horizontal stabilizer goes down and the nose of the aircraft moves up. It's the same concept as your aileron, but with a negative camber. Okay, now moving on to rudder. Now rudder, like I said, is a symmetrical aerofoil. That is, if the rudder is kept stable in a neutral position, the aircraft will not have either movement. Okay, now let's say you apply right rudder. Okay, when you apply right rudder, what happens is that this is your vertical stabilizer and this is your rudder. Okay, so the rudder will also move towards the right side. When the rudder moves towards the right side, the same principle applies here, and lift or force is generated in this direction. A force is generated in this direction. Now what happens is that the entire empennage with the vertical stabilizer will go towards the left side. Now when the back side of the aircraft is going to the left side, the front part of the aircraft will move to the nose of the aircraft will move to the right side. Okay, so this is basically how rudder moves. Similarly, if the rudder moves to the left side, more force on this side, so the entire empennage moves towards the right side and the nose of the aircraft will move towards the left side. So this is basically how you control the aircraft. Okay, so now I am sure you have understood what is stability of the aircraft and how stability is being kept in an aircraft, how the aircraft is getting controlled, and what are the control surfaces and how it controls the aircraft, how you can control the aircraft using the control surface. So if you want to go right, you just go right. If you want to go left, if you want to roll left, you roll this side. If you want to bring the nose of the aircraft up, you pull back on the control surfaces. If you want to bring the nose of the aircraft down, you push the control yoke down. And if you want to, rudder is on your legs, so assume this as your legs. If you want to go to the right side, you press the right pedal, and if you want to go to the left side, you press the left rudder. So this is basically how the controls of the aircraft is how the aircraft is getting controlled in. And so the stability and controllability of the aircraft has to be in balance. So when it has to be in balance, now when the control surface is moving either deflected upwards or downwards, now we have to remember this is that the air is flowing, okay, above and beneath the control surfaces as well, and now the air has a tendency to push it back to the neutral position. When it has a tendency to push it back to the neutral position, what happens? The control surface in turn gives a reciprocal, or it in turn gives it in turn gives a force called the stick force or the hinge force or the feel. In some pilots call it as the feel to the control column. Okay, so this acts as when the pilot is turning this way or the pilot is moving the control column into the right side, the aileron, which is that is if you're going to the right side, the right aileron is moved up. So when the right aileron is moved up, what happens is the air that is going around this aileron is trying to push the aileron back to neutral position. So that in turn, that movement, that force that the aileron is experiencing, in turn is connected to your to the control column, so the pilot can have a sense of feel. Okay, this is called as feel or stick force or hinge force, whatever you call that. It's basically giving the pilot that how much he or she will have to deflect each and every control surface. So this gives a sense of controllability towards the pilot, for the pilot. So this is basically how the stability and controllability of the aircraft works. I hope this video was very informative for you, and so please go through our videos, like, share and subscribe. Thank you all of you, and have a wonderful day.